We'll proceed in parameterization, Jacobian 2D, 3D in calculus. What is kind of myth in coordinate system? Why we need different coordinate system? Now it is pretty clear. We need different coordinate system because we cannot solve everything in Cartesian coordinate system. How a cylinder, if I have a cylinder, if I have a cylinder, then how a cylinder looks in cylindrical coordinate system. If I have a circle, if I have a circle, then how the circle looks in polar coordinate system. If I have a sphere, then how a sphere looks in a spherical coordinate system. No one thinks about it. When I see a circle in Cartesian coordinate system, that is x-axis, y-axis, there is a circle where y equal to a square root of 1 minus x square, square root of a square minus x square, square root of a square minus x square. This is the y equal to. This is the equation of a circle. Means x square plus y square equal to a square. A circle, a circle in Cartesian coordinate system looks round, where y equal to the square root of a square minus x square. I say I want to denote, I want to represent this circle in polar coordinate system where x equal to a cos theta, x equal to a cos theta, y equal to a sin theta. Then again it is a circle in Cartesian coordinate system where from x-axis the angle is theta and this is the radius a. A cos theta is x-axis, a sin theta is y-axis. What we are trying to do here? We are mixing theta and x-axis. We are mixing theta x-axis, radius a and y-axis. What about in polar coordinate system? How a circle looks where the coordinates are theta and r only. There is no concept of x and y. It looks like a rectangle. Can someone believe it? The circle, what we see in Cartesian coordinate system, it looks like a rectangle in polar coordinate system. The cylinder that looks cylindrical in Cartesian coordinate system xyz, it looks like a cube, cuboid in cylindrical coordinate system. If I have a sphere that looks a sphere in Cartesian coordinate system xyz axis, it is a cuboid in a spherical coordinate system. What is the volume of a sphere in a spherical coordinate system? R theta into phi. If that is the three independent component and it is cuboid, that is the volume. No, 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 no. Volume of the sphere is 4 pi r to the power 3 by 3. That is in your Cartesian coordinate because it looks like a sphere. Similarly, cylinder and similarly circle. What is the area of a circle in pure polar coordinate system? R into theta. But when it transforms into Cartesian coordinate system xy, then x equal to r cos theta, y equal to r sin theta, and it makes an arc with this equation, and this is called parameterization. If I have some rectangle in r theta r plane and I am mapping this into xy plane, one plane to other plane, if there is a mapping, there is a mapping function where x equal to r cos theta, this is a mapping function. I can say x equal to g theta comma r, y equal to h theta comma r. Then it looks like a circle in xy plane. Okay, can you see the equation of the circle in xy? Y equal to square root of a square minus x square. It's not a straightforward. It is kind of quadratic. Quite square root. It is kind of quadratic. If that is the case, then this is how it is. Now, where it is useful? Why we are talking about parameterization? Theta r plane to xy plane, and there is a function that is mapping xy plane to theta r plane. If that is the scenario, then there is a function x equal to g theta r. This is called parameterization. G is a function and theta r is parameter. Y equal to h theta comma r. H is a function converting theta r into y, theta r into x. So this parameterization has two forms. One is in algebraic equation, another is in parametric vector. If I have x, y, z, x, y plane as independent and z or function over x and y is dependent, then any point on the surface I can represent as xi plus yj plus fxyk. If this xy dependent component is mapped into theta r, that theta r is now new independent component, then same p point is xi plus yj plus zk. I can represent it as parametric vector, where p would be renamed into r, that is parametric vector r as a function of theta and r, equal to g theta ri plus h theta rj plus f function g theta r comma h theta r double bracket close k. Okay, so that is the scenario of the parameterization. Now we are, why parameterization is important? If you remember, in last video we talked about the calculating the voltage across a capacitor in RC circuit. If I have RC circuit, resistance and capacitor in series circuit connected to a voltage source Vs, then voltage across capacitor is function over time. When at time 0 there is no voltage across the capacitor, slowly the capacitor resistance initially it will show as 0. Slowly resistance would build up and it will come infinite and it will stop the current. Whatever voltage is available at that time, that is called saturation voltage. So whatever the, if voltage is climbing from 0 to maximum, even though full voltage is supplied to it, it takes time. Then what is the function of this voltage as per the time? Voltage as a function over time. So what is that? Then if you remember, we came to a situation where we have V, that is the any time voltage across the capacitor, V divided by Vs minus V, where Vs is the voltage source battery. There is a RC circuit RC connected to a battery Vs RC circuit. Then any moment the voltage across capacitor is V, then dV by Vs minus V equal to minus dt by RC. This is what we saw. Dt I can compute integration to bring it t, but V I cannot compute integration because it's not dV by V. If it is dV by V, I can say it is logarithmic of V. It is dV by Vs minus V. God said, don't give me this example. I cannot do. dV by Vs minus V, how I can do? dV by V I can do. Okay, if that is the scenario, then method of substitution comes into the picture. Method of substitution is nothing but you have V and T plane, or V plane. From there, you are taking help of another plane. If V coordinate system is there, another coordinate system called U, function over U, V, function over V. So U equal to Vs minus V. If U equal to Vs minus V, then du equal to minus dV, dV equal to minus du. Now you can substitute minus du divided by u, minus I can take that side, so it becomes ln u equal to minus t by rc. Now I had to calculate v, but this is the coordinate system v and function over v. I took example of another. I took help of delegation. I took help of another coordinate system, that is u. So now computation happen in U. There is a relationship between V and U. Vs minus V equal to U. I mean V equal to Vs minus U. That is the relationship. V equal to Vs minus U. Now when I could do it successfully, now it's time to get back to V only. So it is ln U. Ln U is the net integration. U equal to Vs minus V. So ln Vs minus V. Integration is V is 0 to V. That is the integration. Voltage starts from 0, it comes to a level V. Okay, so top first we will assign the top one, that is it is ln Vs minus V minus ln Vs, that is ln Vs minus V divided by Vs equal to minus T R by C. If we settle it down, then it becomes Vs minus V equal to Vs e to the power minus T by RC. If I take it here and there, then V equal to Vs minus Vs e to the power minus T by RC. Vs in bracket 1 minus e to the power minus T by RC, where time is called, I believe it is called time, some constant tau. When it becomes RC, then it becomes 1, whatever. So voltage, any instantaneous, any momentary voltage, variable voltage at the capacitor plate at any moment, V equal to Vs 1 minus e to the power minus T by RC. This is method of substitution. This is parameterization. Parametric vectors are used in calculation of area. Okay, so here if I go even in depth, dV by Vs minus V equal to T by RC, that is the net equation. Now dV equal to dV by du into du, 1 by Vs minus V into dV by du into du. dV by du I have to find. Anyway, Vs minus V equal to U. So 1 by U into dV by du into du. This dV by du that I need to find, that is called Jacobian. So single dimensional Jacobian, simply you can differentiate and get the Jacobian. But two-dimensional Jacobian, you have to go with the area fundamental. Please please watch our, lot of people are watching. Please watch our previous videos. How to get, if I have component like the way we were. Now let's take example. We are in discussion for example, I remember. There is a reason in xy plane where x is 0 to 2, y is 0 to a square root of 2x minus x square. Integration is square root of x square plus y square. Dx dy. Dx dy is nothing but xy plane. This is xy plane. This is origin. This is xy plane. Now there is a surface, equation is square root of x square plus y square. Surface with equation is x square plus y square, a square root. Okay. Now integration over a region x equal to 0 to 2 and y equal to 0 to square root of 2x minus x square. What is this region? Problem with any book is directly they start jumping into the solution, and this is the answer. Whenever you get a difficult problem, whenever someone is in difficult situation, better to draw a graph. What the problem is, take time, probably 30%, 40%, 50%, 60%, 70%, whatever it is. Take time to understand the problem. Then how I'll get the solution? Solution is always hidden in the problem. Solution is never comes as different entity. If there is a dynamo and there is a coil, if someone moves the magnet in the coil, then it brings the energy. Then that is the energy that is positive. What about negative? We see two wire, right? Positive and negative. Positive and negative comes together only. So in energy, positive and negative, wherever, if there is a positive energy, negativity will come together only. So if there is a problem, solution is always hidden in the problem. In examination, people see problem and someone has to find the solution. Solution is hidden in the problem only. You have to go little in depth and you will get the solution there only. No need to remember the book, what was the solution for this problem. Solution is always hidden in the problem. Problem is always hidden in the solution. If I know the solution, then problem is hidden thereof. So I am not saying this. This is written in Gita. That is the religious book in India called Gita. Things comes together always. So if there is a problem, solution is hidden there only. So if I have a reason, what is the reason? X is 0 to 2 and y is 0 to square root of 2x minus x square. So 2x minus x square can be written as 1 minus x minus 1 whole square. 1 minus in braces x minus 1 whole square root. Y equal to square root of 1 minus x minus 1 whole square. That is nothing but x minus 1 whole square plus y square equal to 1. This is nothing but a circle. Circle which is centered at 1 comma 0. Okay, there is this is y axis, this is x axis, this is origin. The circle is here, not centered at the origin. If it is centered at the origin, circle is here. But if it is centered at 1 comma 0, then circle is here. 1 comma 0 it is centered. X minus 1 whole square plus y square equal to 1. Okay, so x is 0 to 2. So if this is origin, then 0 to 2. 0 to 2. Okay, like if this is the, if you understand parameterization, then calculus is done actually. If this is the origin, the circle is like this, centered at 1 comma 0. So x is from 0 to 2 and y is 0. Y is, oops, 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 y is 0 to variable. Y is not constant. So along the parameter. But it is not below the x-axis. 0 to a square root of 2x minus x square. So means upper half of the circle is the region. What is the region in 3 dimension? In 3 dimension, if I have a surface, if I have a surface, this is xy plane. If I have a surface, the surface would map to some region in xy plane. That region is semicircle. Okay, I have to integrate this fxy along the xy plane where x and y, this value must come from the semicircular region only. Not, you have to not go beyond it. That region only x and y would come from. Understandable? So square root of x square plus y square dx dy. Then x is 0 to 2, y is 0 to square root of 2x minus x square. That is under the question. Now straightforward one would jump. Square root of x square plus y square. First, since y is in function of x, first I have to integrate with the y. So square root of x square plus y square. Then if I integrate with dy, who has courage to integrate a square root of x square plus y square with dy? Considering x is constant, still I believe it will come in some tan, arc tan inverse of, it is very complex. Whatever it is. If someone calculates it, then congratulations. Even I will try in Cartesian coordinate. No, it's very difficult. The square root of x square plus y square dy is very difficult. Whatever it comes, then you have to limit 0 to the square root of 2x minus x square. First you have to place in y square root of 2x minus x square, then y 0. Whatever the big expression comes, then I have, again you have to integrate with the x and then 0 to 2. Now I have to delegate this to another coordinate system for easiness. So let's consider x square plus y square. It is tempting, it is circular, right? It is tempting to use coordinate system, polar coordinate system. So x equal to r cos theta. Why r cos theta? If I know the circular region has a radius of 1, then I can take x equal to cos theta. No, because there are two independent variables, x and y. So I have, and we are talking about independent area as a region. We are not talking about an arc of a circle. Like if there is a single dimensional x-axis and there is an arc and I have to calculate the area, then I need arc equation where radius will be 1 fixed. But I have to calculate along a region. Please concentrate. So I have to calculate along a region. So here, if it is a region that is an area, two independent components would come into the picture, r and theta. So x equal to r cos theta, y equal to r sin theta. Then x square plus y square, a square root would become r. Now dx dy, dxy plane is nothing but dxy by d theta r into d theta r. D theta r, at the beginning we talked about what is theta r plane. It is rectangular region. So d theta dr. Similarly dx dy. But dxy by d theta r, this Jacobian I have to calculate. So dxy by d theta r is nothing but dxy by d theta into dxy by dr, dy by d theta, dy by dr. If I calculate this determinant, it will come as r. So r into r d theta dr, r square dr d theta, that is r to the power 3 by 3. Simple, right? R to the power 3 by 3. But what about the limit? X is 0 to 2 and y is 0 to square root of 2x minus x square. Now convert it to theta and r. Hey, what is this theta and r? I know semicircle. So theta will go and semicircle. So theta will go 0 to pi and r will go 0 to 1. Okay. Now let's proceed. That's why I say understand the problem clearly. What is the problem? What is fxy? What is z? Square root of x square plus y square. What is z value when it is at origin? 0. When it is at origin, when it is at origin, there z is 0. As you move along, z will be higher because x and y will be higher. Can you imagine the 3D model? So at the center, there is no z and it will go like this all along, like a flower. Okay, I don't have the flower. I could have brought it. So at the center, it is at origin only, and flower, it goes like this. Every side, omni, it will go and it will go up, 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 up. Flower will go up and it bends, but it will go up like this, all side. Now, the reason on which I have to calculate the integration is not centered at the origin. This circle is not semicircle, is not centered at the origin. Rather, it is shifted one. Now it is like this. Can you see the origin? Blue color. It is like this. So, but our algebraic equation from center, it is like this. But I want the calculation in this in upper half of the circle, but circle lower portion is touching the center. Okay. Now, if if I wanted the region to be calculated centered at the origin, then theta equal to 0 to pi, r equal to 0 to 1. Simple, right? But the reason I want is shifted from the origin. Left end of the region is touching the origin. Right side is touching the 2 point. And then, so the graph, 3D graph where it is, has origin and it is emanating like this. So our region is not centered at the origin. Right side we are taking. If right side we are taking, then R we cannot take. R means from origin. because we have taken x equal to r cos theta, means it is centered at the origin. Y equal to r sin theta, it is centered at the origin. No, 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 I don't want. I want center at the 1 comma 0 only. Then x minus 1 equal to r cos theta. Y equal to, accordingly you have to find. It is difficult. Or who stops you taking x minus 1 equal to r cos theta, y minus y equal to r sin theta? If that is the case, then Jacobian would be the same, I believe, r only. Then x square plus y square root, you have to settle it down now, because x minus 1 equal to r cos theta. Then limit will be 0 to pi and 0 to 1. R will be 0 to 1, x and theta will be 0 to pi. Limit is nice. Now, try now square root of x square plus y square, where x minus 1 equal to r cos theta. Now, it will become a 1 plus cos theta whole square plus sin theta whole square square root. It will come as 1 plus 2 cos theta square root, and then r square, whatever it is. Then r into r. 1 plus, it is, you understand, right? 1 plus r cos theta whole square plus r sin theta whole square. It is, I believe, it is complex. But here it is easy, limit is difficult. What is the limit? Now we understand the reason under which is not centered at the origin, right side. That is the reason, where left side of the reason is origin. So it is emanating like this, not centered at the origin. If that is the case, let's try it out. There is no problem in trying it out. Y equal to square root of 2x minus x square. Y equal to 2x minus x square. Okay. If that is the case, then that is nothing but 1 minus x minus 1 whole square root. This is what we brought, right? 2x minus x square is 1 minus x minus 1 whole square root. If that is the case, then y equal to, so y square plus x minus 1 whole square equal to 1. Okay, what is y? Y is r square sine square theta. Y is r square sine square theta. Okay, or just leave it. Y equal to square root of 2x minus x square. That is the limit. Y square plus x square equal to 2x. It makes more sense. Y square plus x square equal to 2x. Y is r square theta. X is r sine theta. So r square sine square theta. X is r square cos square theta equal to 2r, 2 into x, 2r cos theta. Here it becomes r square, sine square, cos square gone. R square is equal to 2r cos theta. R equal to 2 cos theta. So the limit is 0. When it is 0, then anyway 0. 0 to 2 cos theta. 0 to 2 cos theta. Y equal to square root of 2x minus x square. If y equal to y, then y square plus x square equal to 2x. Then y square r square theta, r square sine square theta plus r square cos square theta equal to 2r cos theta. R square equal to 2r cos theta. R equal to 2 cos theta. R square, understandable. X is 0, then R is 0. Y is r sine theta when r is, when x, whatever, when x is 0, it is 0. So 0 to 2 cos theta. What about x? 0 to 2. Now, since this is the origin and x is 0 to 2, if I take theta, then it is 0 to pi. Can you see? This is y-axis, this is x-axis, this is the origin, and 0 to 2 means if I take this theta 0 to 2 means 0 means pi by 2 to pi, pi by 2 to pi. No, 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 no. This fundamental would not work, sir. You have to tell me the way you calculated the y to r. 0 to 2 cos theta. Here 0 to 2. X is 0 to 2. What would be theta? I don't believe in your those concepts that it will go like this or this. X equal to r cos theta, y equal to r sin theta, y by x equal to tan theta, theta equal to tan inverse y by x, y equal to square root of 2x minus x square, theta equal to tan inverse square root of 2x minus x square by x. Now where x is 0, something by 0 is infinite. What is theta equal to tan inverse infinite 90 degree pi by 2. Now when x is 2, 2x minus x squared, 4 minus 4 0. When numerator is 0, it is 0. Tan inverse of 0 is 0. Pi by 2 to 0 to 2 cos theta, r to the power 3 by 3. So 8 by 3 into cos to the power 3 theta by theta. Now cos to the power 3 theta, cos to the power 3 theta has to be integrated. Limit is pi by 2 to 0. So someone can try calculating it. Now no one stops you calculating it through Cartesian coordinate completely. Square root of x square plus y square dy dx. Try it. We will come with different examples. Can you see how drastically it makes life easy? When you go for parameterization, first think about the new coordinate system what you are going to take. It may not be polar, it may not be cylindrical, it may not be spherical the way took in RC circuit. U equal to Vs minus V. It is a different coordinate system completely. So, not necessarily. It is your mind how it clicks it as per your experience. Limit, be careful. Well, while changing the limit, be careful. This is what anyone would suggest you. Because if you make a minute mistake in the limit, then you will screw down everything. So limit you have to manipulate, and then parameterization, what function you take, that matters. And then you have to calculate the Jacobian, and then you are done. Slowly we will move into 3D also. So then we will go to the artificial intelligence, and we will see real life example how we can solve it. Please support us. Our telephone number is +91, that is the India country code, +91 94831 60610, 94831 60610. India country code is +91. Please do support us, and please continue enjoying.